Welcome, guys. So go back to our physics GRE section. So we start from 6, and before to start, and be sure to subscribe to my channel. So number 6, the particle is initially at rest at top of the curve. Start from here, and after that it become here, and they said that basically this is just set a direction. This is positive direction x, this is negative direction y, and as the particle slides down the track, it's a tangential acceleration. Okay, nice. So what is the tangential acceleration? So basically you have the gravitational acceleration, and what you need to do is find a tangential component of the acceleration. So suppose this angle is alpha. The tangential component is g cosine alpha. Right. This angle is this magnitude is the tangential component. Okay, so the answer is g cosine alpha. So the rest is find alpha. Okay. So let me enlarge the picture. Okay, so it's too large, right? We need to find alpha. So basically, what is alpha, right? So you see, tangent alpha is dx over dy. Basically, this is 1 over dy over dx. So all we need to do is just find the dy over dx, and the calculus tells us that this is this 1. Okay, so the tangent alpha is x over 2, and no, the tangent alpha is 2 over x, because this is 1 over dy over dx. So what we need is cosine alpha. So suppose this is 2, this is x, then the square is this 1. So cosine alpha is g times x divided by x squared plus 4. This 1 over this 1 is cosine alpha. So this is the answer. So the answer is D. The answer is D. Okay. So number 7. Okay, the 2 kilogram hands by a massless rope from sitting, a force is slowly pulls the box horizontally to rise until the horizontal force is 10 newtons. And and ask about and say that it's equilibrium. So equilibrium, and ask about the angle. Okay. An angle is not difficult, right? Because you know that there is a mass term which is 20 newton, and this is t. So they form a triangle that t 10 and 20, and this is theta. So tangent theta is 10 over 20, which is 0.5. So theta is arctangent 0.5. So the answer is A. Okay, so number 8. The 5 kilogram stone drop on a nail and drives the nail 0.025 meters. So nail. Okay. And if the stone is moving 10 meters per second, when it hits the wall, the average exerted on a nail by a stone while the nail is going into wood is at most nearly. Okay, so this is basically the energy conservation. So we have the moment, the kinetic energy, which we can compute, is this one. So we have the speed. Speed is 10 meters per second. So speed equals to the force times the nail, the distance. So the distance is this. So we can solve F is, this is 2.5. So 2.5 times 100 divided by 0.025. So the answer is right, Newton. So we choose D. Okay, number 9. A wire is diameters 0.02 meter, contains 1 times 10 to the negative 28 free electrons per cubic meters, and electric circuit is its current is 100 amperes, and the drift velocity. Okay, so remember there's a old formula said that J is equals to rho V. So rho is the current density. Uh, then J is current density. Rho is the electric charge density. So which is basically this is N times E times V. So basically E just 1.6 times 10 to the negative 19 coulomb. So now we have we need to first use amps and the area to find the J. And once we find the J, then we have this N, and we can find a V. We can find a V. Okay, so everyone knows about process. So the process we use amps and meters to find J, and J equals to NEV. Okay. Okay, so let me do the calculation. So basically, this I is just I over pi d to half squares equals to NEV. So V is I over pi NE half d squared. So nothing can do. You just directly brute force the calculation. Then you can see the answer should be D. Yeah. So there's no way that you can guess the answer easily. You need to do this calculation. I think this calculation is straightforward, so I don't do in the YouTube video. Okay. And then number 10, the isolated sphere radius R contains the uniform or positive charges. So you have R, which is on its positive charges, and ask about the electric field. So this is old school problem. So what we need to find is the electric field dependence inside R. And what do we do? We use Gauss law. So basically, when R is inside R, so we have exponential, not exponential, electric field times 4 pi R squared equals to epsilon not half. This is volume times the density. This one which is constant. So E is equals to. Actually, we don't care about E. What we care is the dependence of E. So the dependence of E is linear in R. So linear in R, only C is linear in R. So we choose C. That's it. And I will see you guys in the next video. Be sure to subscribe to my channel. Thanks.